So I am so happy to introduce Ryan. Ryan Davis has been using Ruby since 2000 and is founding member of the Seattle.rb brigade, the first and foremost Ruby brigade in the world. He is also an independent consultant, and his background includes QA, automation, language and tool development, object databases, and small talk.
They will learn.
In Ruby Rails, he has focused on developer productivity, code process, people optimization, and test automation tools such as Hackle, Hope, Ruby Parser, Ruby 2C, Ruby to Ruby, Ruby Inline, Zen Test, Mini Test, and more. So please let's give him a warm welcome to Ryan.
Hello. How's that? Okay, I'm just in frantic mode. This is great. Welcome. Thank you everyone for showing up and sticking out this long. I don't know about you. This has been an awesome conference, but I personally am exhausted at this point. I am running on vapors. So, setting expectations, something I always like to do in my talks. This is a conceptual / idea talk. There's no code in it, unfortunately. It is meant for beginners all the way on up, but I'm hoping that user group leaders are in the audience and can take some ideas back to their groups. Are there anyone who runs a user group in their area? There's one there, yeah. Awesome. And this is, well, last time I updated this slide, it was 210 slides. And I'm shooting for about 35 minutes in case there's Q&A, so that's about 6 slides a minute, which for me is a pretty normal pace. Showing up to 219 slides. So several years ago, I was Salvador Dali for Halloween. I took a year to grow out the mustache for real. And Aaron Patterson, aka Tenderlove, had one of my photos painted on black velvet to tease me. Recently snuck into his house and put it in the back of his closet. So I'm not stuck with it anymore, but I used this photo for my speaker bio, well, because it's fucking awesome. So I did that for this conference, and I wound up with this luchador mask. And they're like, where'd the mustache go? But you compare. Personally, I love it. So yesterday, Katrina taught me about the law of holes. If you find yourself in a hole, stop digging. I'm not really good at learning things, though. I use pink slides for ink that I have unfinished. It helps them pop when I'm doing the page layout view. Helps me find them quickly and know where I still need to do work. And 1 hour ago, this is what my talk looked like. So, the law of holes is not don't stop digging, it's dig faster. It does imply that this talk is relatively unrehearsed, so please bear with me when I'm rough around the edges. So let's get started. Maybe you're a relatively new developer. You've landed a job, but all you've been doing for the last 6 months is tweaking CSS or writing tests for bad code that someone else stuck you with. Maybe you're an experienced developer, and you've specialized so much, perhaps too much, that you feel like you're in a rut. You want something to stimulate, educate, elucidate, and cultivate. You want to do something. I hope you guys hear this. To level up. Oh God, this slide. I'm dreading this slide. Hola. Han pasado 25 años, no recuerdo mucho, lo siento. So if you see me like deer eye at you when you speak Spanish to me, that's why. I'm Ryan Davis. I founded the Seattle Ruby Brigade, which, as you heard, was the first Ruby users group in the world. We just celebrated our 15-year anniversary last month. started a study group. Aaron Patterson, Aja Hammerly, Eric Holdle and I started to read and work through all of SICP, which was a 9-month gauntlet for us because we didn't realize that in college you don't do every problem. But we branched out with workshops, challenges, and other forms of collaborative learning. And I'm here to share some of our experiences of what works for us. But I need you to remember that this talk is not definitive. There are many study groups like this, but this one is mine. What works for you and your group will be up to you and your group. So let's get started with study groups. What does it mean to level up? Well, for me, leveling up means learning. It means improving your skills or adding skills. So what does it mean to learn? For that, we're going to take a brief tangent into models of learning. There are probably hundreds of models of learning. I'm only going to cover 3 of them very briefly. Shuhari describes the stages of learning that originated in a book about Japanese tea ceremony, but quickly got adopted by Aikido and spread into other Japanese martial arts. It's a bit too woo for me, but maybe you'll like it. Shu is the fundamentals and techniques. It's learning and sticking to rules. Ha is breaking of tradition. It's the detachment from the illusions of self. And Ri is transcendence. It's that there are no techniques or proverbs anymore, and you transcend the physical. The Dreyfus model describes the stages of learning in education and operations research. It's a bit too stuffy for me, but maybe that works for you. My eyeballs. It goes through 5 stages. The first is novice, which is rigid adherence to taught rules. It moves on to advanced beginner, in which you have limited situational perception. Then you become competent at something with deliberate planning and formulating routines. Then you become proficient at it. You develop a holistic view of the situation, and by that time you're now an expert with an intuitive grasp of the situation based on deep, tacit understanding. It becomes unconscious. Personally, I think this is too complex, and I think that they miss out on explicitly declaring a stage 0, which is when you are ignorant of your ignorance. The 4 stages of competence describes the psychological states of learning. It's just right for me, and this is my favorite. Basically, it sets up a simple progression from not knowing what you don't know, at level 0 that I was just implying, to having an unconscious mastery of something. But I'm slightly addicted to putting things into 2 or 3 dimensions. So adding the unconscious to conscious axis and the incompetent to competent axis allows those 4 stages to lay out a table like this. But even that's a bit muddled for me. It's entirely equivalent, but it's perhaps a bit hard to see that they're traveling clockwise provides a linear progression. Taking that one step further, simplifying it down to the basis terms of wrong intuition, wrong analysis, right intuition, this is like almost something that you want to get tattooed. I love this cable. I'm not going to get it tattooed. But I do like it a lot. I think it describes it very succinctly and very well. So you use these models to understand or score how well you or a group or whatever understand or do something. On a Dreyfus scale, this might be how I map out a number of skills. I'm an expert in Ruby and object-oriented programming, and I utterly suck at R, and always will. I've tried, I just will. Or maybe you're looking at a team of people in one skill. In this case, Mary and Sue can answer nearly anything Ruby, and John needs the most help. It allows you to be able to focus in on what you need to focus in on. Once you know where things are weakest, you can focus on improving them. But what sort of improvements are available? Assuming you have a group with varied skill levels and an average for the group, you can focus on bringing up the group to a minimum level. Some might have to improve more than others, but it's less effort to bring up red a step than it is yellow a step. So it's not that much more effort to get them both to the same level. Or you can focus on an even improvement from everyone. Each person basically studies the same amount at their own pace. It turns out looking at those two, that you're bringing up the average the same amount regardless, in the case of these numbers. Or you can focus on an individual skills. You can improve one existing skill, or you can add a new one. So, that's the last one, I promise. How does one actually level up? For me and my cohort, that involved forming a study group and working through a lot of hard material. The benefits of adding a study group to Seattle.rb, well, the first one is learning. Duh. The other is that it was orthogonal to our regular group. We would lose people if this overlapped. It bore some from the regular group, and it would be too much to deal with for people who wanted to do the study group but also wanted to socialize. And of course, there's consequences to having one as well. We are definitely asking for more time commitment. And for the organizer, at least, me, there's the disappointment of seeing the enthusiasm dissipate as people realize that this shit is really, really hard. When we did a book called The Realm of Racket, we had a huge number of people who signed up when we announced it, and not so many at the end. This is my disappointment, visualized, and fitted to an R-squared of 96%. There are also differences in the types of groups you have. In the case of a professional study group, it's paid for and it's scheduled, sort of, usually, ideally. But it goes by the beat of the slowest drummer. As a result, it is often less challenging or runs at a slower pace. Ooh, shit. Runs at a slower pace. And in the case of the corporate stuff, every time I've seen one, they are seeking group success. And for that, that might mean a group understanding on a new topic. It might be being on the same page or consensus on some new idea. In comparison, amateur study groups are out of pocket, on personal time, but they tend to be faster moving, more adaptable. They're generally harder, but they have more customization on a per-person basis. And all the times that I've seen, we seek failure and to understand where our personal boundaries really are. One more thing to take into consideration is a basic formula for change. So D times F times B times F greater than R, where D is a dissatisfaction with how things currently are, B is the vision of what is possible, F is the first concrete steps that can be taken. Because those things are a product, if any one of them is incredibly low or zero, it's going to negate any ability to overcome the resistance to change. This might be more relevant for corporate study groups, but it is worth thinking about even on a personal level. So what have we as Seattle.rb Brigade Study Group, which is a mouthful, done? Mostly books. Like I said, we started with Structure and Interpretation of Computer Programs. It's a classic CS text from MIT. It's very mind-bending. Jim Wyrick did a really good talk on this several years back at Goguruko. It's on Confreaks, and he goes over just a small portion of it, a very small portion of it, and did a great job of illustrating why that book is so good. It is fantastic, but it is also very, very dense. Like I said, it took us 9 months. Don't do every problem. Don't even do every other problem. The next thing on this is not in chronological order, and this is not in any order of preference either. Another thing we did was a program that is unofficially called Nanda Tetris. It is by far the best computer science curriculum that I've seen to date, hands down. You start with the NAND gate, the not and gate. You build up all of logic. With that, you build up both an ALU and a memory system. From there, you build up a CPU. On top of that, you build a compiler for a simple language. And with that, you write an application. And you see exactly how your wizard box works. That thing in front of you, despite the fact that what was the number of transistors yesterday? 20 giga transistors or whatever. This is obviously a much simpler computer when it's a computer. It is how your computer works. And by the time you're done with this 12-week curriculum, you know how your wizard box works, all the way down. I love it. The Little Schemer, this does in 10 chapters what many CS programs can't do in a year or two. It seriously challenges SICP, and one of the things that kills me is that it starts from absolutely nothing. It has no expectations that you know how to code. It is also a strange fucking book. It's written in Socratic dialogue. It has no exercises. It can be done entirely on paper. In fact, they don't have exercises or expect you to do anything in a computer at all. It's made for you to think about this thing. The Season Schemer continues where the Little Schemer left off, and it goes even deeper, way deeper. And the Reason Schemer is the third book in this series, sort of. It's incredibly mind-bending. It's logic programming built on top of Scheme. And by mind-bending, I mean it implements a logic system via breadth-first combinatoric search of potentially infinite streams created by language-generating randomness. That is exactly what it does, and it took us quite some time to figure out what that sentence meant. Little Prover just came out last year. We were very excited about it until it kicked our ass. It implements a proof system in Scheme. It's incredibly hard. We failed in 2 to 3 weeks. We did an online course called Simulation in Nature and Design. It's from a professor at MIT Media Labs. You implement lightning and fabric and sand and clouds and all sorts of shit in nature using math that I still don't understand. We failed that one in 3 to 4 weeks. Build Your Own List. That URL is a little small now, but it is literally buildyourownlist.com. Uses C to implement the author's variant of a simple list language. The curriculum is pretty flawed, but I personally stuck through it to see the contrast in teaching styles against Little Schemer and other things, so that I could see how I didn't want to teach things myself. Not me, but a different group studied Elixir, studied the 2 basic books, and they wound up actually splitting off into their own user group, which I think is awesome. Another group also did Sandy Metz's Pooter. I didn't, but I heard from many of the beginners that it was really, really good. We tried to do the essentials of programming languages. It's incredibly hard. It is learning what programming languages do by implementing all the different features of various types of programming languages. We failed that one in 2 to 3 weeks as well, but I think we failed that one because we were burnt out in general, not because of the book itself. And then a number of us tried to study Rust using a mix of exercism and online puzzles, like Advent of Code and others. And I don't like the language. I don't think that's their fault necessarily, but I'm going to put the blame on them. We also did a number of workshops and challenges. One was the R-Tank challenge, where we build and battle tank bot brains. Is that video? Yeah. Tank bot brains for fun and profit in a group arena. And by profit, I mean we actually got people to sponsor monetary prizes, and that actually got the beginners in our group to get really involved with it. And it turns out they won. I spent a lot of time on the math of my targeting system, and I got my butt kicked. A lot of time. We also did Project Euler, which is abstract algebra and number theory. The intent is that you solve some math problem that they describe, and your solution needs to have less than about 2 minutes of computation time. We also got sponsored money for prizes on this one, and we split up the prizes for anyone with 1 year or less of experience and the rest. And that allowed us to have a level playing field on the competition. Katrine talked about many of the problems with exorcism yesterday. What we liked was that it was easy to get a lot of potentially useful critique from outside perspectives, but it does have its drawbacks. In particular, I think that depending on the language, it can be pretty weak from a pedagogical perspective. We also did Rosalind, which is genomics and bioinformatics puzzles, much like Project Euler, except that unlike Project Euler, which is just 300 some odd problems that you just do anytime you want, this has kind of an RPG-ish level tree where you have to unlock certain problems by solving their prerequisites. That addresses a lot of the problems from a pedagogical level, but it gets hard really fast, and eventually we petered out on it. None of us have bio backgrounds at all, so we were learning all of the biology at the same time we were doing the problems. And then finally, the advent of code. I loved it. I loved it a lot. It is 25 days worth of puzzles, 2 puzzles per day. The first one unlocks the second one, and it's a twist on the first one. Really good challenges. The solutions go anywhere from instantaneously to it takes many, many minutes to figure out you're wrong. And some of the problems actually require brute force, because some problems do, like there's blockchain problems and other things like that. But most importantly for me is it was a lot of fun. What we plan on doing in the future, potentially, was 99 bottles of goop. A number of people are excited about this. I don't know much about it, but I think we're at a group that's already starting up on it. A book called Purely Functional Data Structures. If you're thinking about doing Elixir or anything else that has immutability in it, you want to look at stuff like this. Oh, that doesn't fit anymore after I fix it. Functional programming through the lambda calculus is symbolic maths only. You can do the entire thing on paper or just in your head. And it's the fundamental theory behind a huge model of computation that you should know about. A book called Lisp in Small Pieces, which is about 7 chapters. Each chapter being a completely different implementation of Scheme, each one getting more complex but also faster or smarter or whatever. Learning to a Haskell for a great good. Oh, where's that? That's on their website. I love that. It's an entertaining book on Haskell. It's often compared to Wise Pointed Guide, so if you like that style of writing, you might like this book. It doesn't work for me, but neither did Wise Pointed Guide. I'm excited about this one, the Haskell book. It seems really good, especially if you don't like learning to a Haskell. It's got, and it's also not like a lot of the other Haskell books I've seen, which have, they just come at it like a nerd would come at it instead of teaching it the way it should be taught. This book teaches the way it should be taught, and I like how much I've worked through so far. Book on POA called Cause and Effects, which is logic programming. If you haven't done logic programming, you should. It'll change your brain. It'll change your brain in a weird way, but for good. And Tom Stewart's Understanding Computation. The one thing I've heard about it that kind of warns me off of it is that it might actually be too good at breaking things down, such that the problems are no longer challenging. I don't know if that's a good or bad thing. We wind up learning anyway, so whatever. And finally, Paradigms of Artificial Intelligence, which is a classic AI textbook. So, what have we learned in the 7 years we've been doing this? In no particular order. Embrace failure. You may have noticed that I talked about, I don't know, 50% of them being failures for us, where we crapped out on what we were studying. Personally, I love that. Really. Because failure is feedback. I know I'm learning something valuable when I'm failing at something. I'm at the edge of my abilities. I'm pushing my abilities. It means I'm uncomfortable, I'm potentially frustrated, but that means that I'm learning something real. Likewise, embrace being uncomfortable. If you aren't uncomfortable, you're working within your competency, and you're not stretching yourself. You're not learning. Oh, this is too long now. Blah, blah, blah. The gist of this is that we were working on the Reason Schemer, which was implementing the logic programming system in Scheme. And this infinite stream of possibilities, generating more infinite streams of possibilities and combining them in this weird, zipping way so that you get a first search of the combinatorics of your possible, let's say, facts. Broke our brains. And And we spent hours in front of the whiteboard going, no, I think it looks like this. No, I think it looks like this. And eventually, like, we did kind of figure it out. We got kind of intuitive understanding of how the thing works. And it wouldn't have happened without that whiteboard, without, like, being uncomfortable working through this thing. Study outside material to push yourself. You may have noticed that there were 2 Ruby books in that list. That's intentional. Other languages bring value. Other models of programming bring value. Sometimes with the intent of bringing those ideas back to what you normally do, and sometimes you study outside material just to change your own brain. Understand what success means for you or your group. It's incredibly custom. What does success even mean for this group? Well, sometimes it's simply a matter of surviving the book that you're working through. Sometimes it means that at the end you need to have a working prototype. Maybe it's just about being able to improve your beginners to intermediates and giving them up a hop or 2. And sometimes it's just getting your toes wet with a new skill. I highly recommend having a group repo structure. We have 1 code repo per study group, so per book or website or whatever. And under that, we have GitHub usernames. And what that means is that everyone's working in their own subdirectory, so there are no conflicts in the code when you're dealing with pushing your commits. And it maximizes collaboration. Everyone gets to see everyone else's commits, so there's only one place you need to go to see what people worked on that week and be able to comment on or anything else. Otherwise, you have to bookmark like everyone who's involved and go off to their forks of a repo, and it's kind of a pain in the ass. Since there are no conflicts of any kind, there's no need for merge commits. So in order to help with that, you can create these Git aliases. Down equals pull dash rebase, and on up equals push. And then to push your code, you just run git down and git on up. And that makes you part of the James Brown School of Git. Have a mix of skill levels if you can. It's sometimes hard when we're talking about, ooh, there's this really hard book we want to do. Because beginners aren't going to want to necessarily jump into something that's hard or that deep. But getting a mix of beginners and non-beginners together is good. Having beginners brings in new viewpoints that experienced people might be too stuck on to think about. And having non-beginners enables quicker leveling of the beginners. There's quicker knowledge transfer. And I like this point. You don't need to have an expert driving the group as long as someone's passionate about it that's pushing people along. Finally, have code review. Not necessarily finally, I have no idea. This is in practice. Have code reviews. Getting reviews from each other in every direction possible ensures that we're all on the same page. It helps new developers learn and understand idioms and get new ideas, or bring new ideas. Yes, new ideas, blah, blah, blah. My notes are terrible. And having advanced developers helps the advanced developers learn how to give constructive criticism well. Something that not everyone's good at, but being in a personal group, not reviewing stuff over the internet with strangers, means that you work on your language and how to present things and how to convey ideas. It also gives exposure to new ideas. And it does all this stuff really, really quickly. You're face to face with a lot of this stuff. You know these people. You know how they think. You know how they talk. It's one of the fastest forms of knowledge transfer that I've experienced. The only one that I've experienced that's faster is pairing on something. But that's a different activity entirely. Have Slack or email or some sort of offline medium available. It enables a high level of communication when it's necessary. And those things are like Slack, not always high traffic, so it's nice when you need it. Sometimes you're stuck at 2 a.m. and chat makes it possible to help someone or get unstuck at any hour. Sometimes you want to verify that you're going in the right direction. And sometimes you just want to share a recipe of braised short ribs. It's nice to be able to have it. Sometimes you want to rotate your leader per study group. It depends on the level of enthusiasm on the topic, but it helps get the ball rolling. Sometimes you need to rotate your leader per chapter. They can organize and sometimes bring questions to stimulate discussion. But it also prevents burnout if the topic material is harder. Sometimes when you're going through a 12-week gauntlet, you cannot be the one who brings the questions every time. You cannot be the one who's wrangling anything. You need to be able to back off so you can just focus on studying. Build a corpus of documents to help your group. Even if it's just having a glossary of common variable names and what they mean, it helps a lot. Sometimes it's common variable names, sometimes it's common classes and methods that you're going to be using. Sometimes it's just URLs to good resources that actually help. I recommend this for everyone who's beginner to intermediate. Have a 30-minute threshold for being stuck. Allow yourself to bang your head on the desk for 30 minutes. After 30 minutes, if you're still stuck, you need to stop. Walk away, take a walk, or eat a meal, or whatever. Go watch cartoons. I really don't care. Just make sure that you're not thinking about the problem anymore. After the break, you must seek help from someone else. Sometimes you're just not using the right words, and Google's no help. Sometimes you've gone off the deep end and you're implementing a relational calculus for something that has nothing to do with needing a relational calculus. Getting outside advice can bring you back on track and quickly. Use books. I'm old, older than some people who said they were old and jaded yesterday. So maybe I'm a bit biased, but it seems like whenever there's, whether it's a study group or book club or whatever, I feel like there's more discussion when an actual artifact is involved. Oh my God, one time. When there's something that you can touch and point at, when there's something where you can remember, oh, it was on the left side near the top, it seems to stimulate more discussion. The online resources just seem to fall flat in comparison. And be flexible. Choose the homework each week. Adapt as needed. We found on some of our books that had very clear curriculum laid out, a syllabus laid out for 12 weeks, that we needed to do 14 or 15. 3 chapters just needed more work that, pretty much everyone, or even just a minority, said, it would be really good if we slowed down on this one and understood it better. What would I like to see change in our own group? I would like us to start repeating material. Perhaps even having an official curriculum for the Seattle.rb study group. We have Ada Academy and Code Fellows and at least 2 other boot camps in our area. So that means that we have brand new programmers every 6 months. And as such, when we've done Little Schemer 4 years ago now, if we don't revisit that, they're not going to benefit from it unless they start up on their own, but they don't even know about the damn book. So maybe we want to have a prerequisite, maybe Chris Pine's Learn to Code as the entry book to get up and running. And then follow that up with Sandy Metz's Cooter. From there, we might want to have Little Schemer, and then finally, Man the Tetris. I cannot emphasize enough how awesome this curriculum is. Please go look it up. Just Google Man the Tetris. I believe, if not the entire book, then many of the chapters are available online. And maybe add more than just that. I like the idea of having 4 books with 1 per quarter, we repeat it every year. At the same time, maybe they don't all fit a quarter very well. I don't know. I would also really like to have more diversity in our groups. I'd like to have more women. We do have some, but we don't have enough. More people of color. Kids even. We actually had a really awesome presentation from, at the time, I want to say she was 7. come and give a talk about how she was working on an Arduino system. I don't remember which Arduino system, but it was one of the mobile ones for making a cat tracking collar so she could see where her cat went while she was at school. And it turns out her cat went everywhere. I'm not sure how to increase the diversity in our groups, and I would love suggestions if you have them. And I just hit my time, and I just hit my last slide. So thank you very much.
Thank
I'm
you,
so sorry, I
Ryan.
went 1 second over.
Oh, it's fine. You're fine on time.
Yeah.
I want to know if somebody has questions. We do have time for some questions.
Anyone?
I can barely see, so yeah.
Is there any place where you can share the slides you were putting up?
These?
Yeah.
These will be on my website in a day or two, on zenspider.com.
Esteban, anything here?
Julian, were you raising your hand or were you yawning?
So what's the basic structure of your kind of book study groups? Like how do you break down each chapter? What kind of things do you pull out of the chapters?
Okay, so the question is, how do I structure it for the book-oriented study groups? Well, like I said, each week we choose what we're going to study for the next week, so it's really variable based on the book. For something like Little Schemer or Nan Tetris, they actually really fit. All of the Schemer books are 10 chapters long, and there's always 2 chapters that are hard. So those fit 12 weeks really well. But the chapters do fit 1 week really well without being too much work for anyone. But each week we come along, we go through, we discuss anything that was confusing, we discuss the stuff we liked and didn't like, and there's always stuff. And then from there we go, well, how do we do on this one? Do we want to do the next chapter, or are we going to do a repeat of this one and focus in on these subsets? In the case of the Schemer books, they're in Socratic dialogue, and some of us just did them on paper, some of us did them so that I wrote basically unit tests to assert that I understood what was going on through the book. And if my tests weren't passing, I'd one more time.
So if you don't have like a local office that you can meet up, do you think these kind of study groups would work in like a local cafe or a bar or some like public place?
So does this study group work in something a little less official of a space? We actually do ours in a cafe. And so Seattle.rb is a little weird. I've given a talk on user groups before and what formula really works for us. And the number one thing that makes both a study group and a user group work the best, more than anything else, is meeting every fucking week. And what it means is, less so for the study groups, obviously, but it means that you're consistent, and if you miss one, the lost opportunity, the lost cost is not much. Like, someone says, I gotta take my kid to a game that day, it's not a big deal. They'll just go next week. Less so obviously for the study group, but as far as the space goes and the amount of quiet you need and that type of stuff, we're drinking coffee, we're discussing stuff, we're pointing at the laptops. You don't need to have a quiet space for it, you don't need to have an official space for it, it works just fine. Most of our actual work is going and getting pushed up to Git, so you're doing like the actual reviews and stuff via GitHub comments. And so when you're meeting face to face, it's about the quick knowledge transfer, and you just need words for that, and that works in the cafe just fine. Any other questions? Yeah.
Yeah, for us guys, we're trying to do this thing like the workshop thing. What would be the basic setup for a workshop, like to stay focused and working when you're there?
For working on
Besides the internet connection,
So what do you need to do a workshop as far as resources and stuff goes? Well, it depends on the type of workshop you're doing. In the case of like the tank simulation thing that we did, and a number of other things, we ask that everyone pushes their code up to GitHub. So in that case, you do need a network connection. But we could have just transferred the files around. We wanted each person to submit their own code for their tank. And so we had to get the code into one place because it wasn't client server. It was all run on one machine. We could have done that via USB stick if we needed to, like if the cafe network was shipped that day. But try to structure our stuff so we don't need too much in the way of resources. But it depends on what you're doing. If you're doing a website thing, then obviously you need some network. But if you're just doing the tank simulation, then you don't necessarily.
Okay,
I think that's it.
I think.
Thank you very much.
Yeah. Okay, thank you so much.
Those are all mine and my Facebook. I'll tag you. Thank you. So we have recess right now, but before we go, I want to show you something. This is the